Cooking? It's cooking. Okay, so let's go through the homework, and then we're gonna look at custom array adapters, so that you don't always have to have just a single string in there. Use the default one for your list views, and then if there's time, we'll start looking at Firebase, or at least start talking about Firebase. All right, so for the homework assignment, if I go ahead and run this real quick at the end of class last time, I had you, oh, this is the wrong class. This is our class. Okay, so as of right now, I just at the end of class here, I gave you an example of a list view just showing a bunch of hard-coded strings, right? And then what we were supposed to do is instead of showing strings, show the information about your players, right? And right now our default only shows strings. I'm going to show you how to do a little bit more than that today, but we'll start with this guy. So if I run this, you'll see those Bible books show up initially. And we already have a screen that allows us to add new. For your homework, it was basketball players, right? For me, it's going to be patient records, all right? Because I think that's what I'm reading in, is patient records. But instead of right now, when I put in the information for a patient record and hit create, it just generates that instance and spits it out to Logcat so I can see it. I instead want to save that instance of that object somewhere. And then when I go back to the screen, a string representation of that guy should now be on the screen. Make sense? Okay. So with that in mind, let me just make sure this guy is initially running reasonably. Okay, so this guy looks like that by default. So first thing I'm going to do is we're going to kind of architect this. We're going to draw some pictures. So I'm going to open up Keynote. Close this one and open this one. Okay, so we sort of showed this at the end of class last time, right? Where we're going to have this singleton, kind of a global variable. And on our main activity screen here, this is where our list view lives. And of course, that guy is green. Those list views are. All right. And so the idea is when we leave main activity to go to our patient record activity. So when we go this way, we fill in our form for our patient record, and ultimately a new patient record is created. All right, and that guy's yellow, obviously. All right, so up to this point, what we're doing is we're creating a new patient record here, and then we're just spitting out we're calling it display method, showing it to the screen. What we want to do now is we want to have this singleton, this new guy up here. And obviously singletons are red. And up there, we're going to have a variable. This guy will be a collection of patient records. Okay, so we want to have a whole bunch of patient records that get stored up there. All right, and then so after we hit submit here, we're going to create a new patient record. We're going to store that patient record up here in our core, add it to our collection. All right, then we're going to go back to this screen. And this screen, we talked about the activity lifecycle last time, right? So when this screen reloads, we want to make sure that our list view gets updated with the latest, greatest stuff from our collection. Okay? Now, what we're going to do here is we're actually going to keep track of two collections up here. We're going to have a collection of our patient records, and then we're also going to have a collection of string representations of patient records. All right, so two separate things are going to get created up here because in our default list view, we know how to show lists of strings. We don't know how to show lists of patient records, or in your case, list of basketball players. All right, so I'm going to go ahead and store my full patient record objects just in a collection, so I have it. But I'm also going to have a copy of that. I'm going to get a string representation of my patient record and store it in that collection. Make sense? All right, so my singleton is going to hold two pieces of information, two arrays. Okay, patient records and string representations of each of those patient records. Effectively, maybe the same thing that the display method's currently spitting out to the screen. Maybe I just hold that, get that as the string representation of it. Okay. So let's go ahead and just get this piece built over here. So from this screen, we're already creating our new patient record, but now instead of displaying it, we're going to go ahead and we're going to put it into our collections up here. Make sense? Let's build that piece. So we'll come back out here. And did I already build my singleton in here? I did. So here is my singleton. All right, so I gave you as an example, we have a collection of patient records here. And I went ahead and I set it as we can have a maximum of 1,000 patient records. Realistically, we probably won't have that many, but arrays, we have to build it big enough to hold everything we want to hold. Shortly, we'll look at linked lists and how we can kind of repair that a little bit, make it a little bit cleaner. All right, now I'm also going to create a second collection. I'm going to say private static, and this guy's going to be a string array. And we're going to call this guy the patient, let's call it the patient strings. Okay, and this guy's going to be a new string array, also of size 1,000. So this is going to be just an array that matches up to my other array. So I have two collections up here. All right, along with a variable that just keeps track of how many patients I have actually added. Make sense? All right, and notice we already wrote a function here, add patient record, that takes the patient record as a parameter. And what does it do? It goes ahead and adds that guy to my collection of patient records. So I want to enhance this now and have it also add the string representation of that guy to my collection of patient record strings. So I'm going to have to teach a patient record how to go ahead and give me a string representation of himself. So we're going to go ahead and we're going to override the ToString method. Remember we looked at this last semester where by default, if I were to do this, let's assume that I didn't override this guy yet. If I were to come in here and I were to say core dot the patient strings at bucket core dot number of patients equals pr.toString. pr.toString, the generic, the default version of ToString for an object, gives you the crazy looking memory address thingy. Right? So if I do a system.out.println pr, I'll get a memory address. So instead of that, I'm going to go ahead and override that ToString method to give it my own version of what I want it to mean when we print out a patient record. Go ahead.
Casts don't work in this case.
Well, what do you want to cast it to?
A string.
So you're going to cast a memory address to a string?
I mean, my pr.toString gives you a memory address.
It gives you the string representation of a memory address.
Yeah.
Yeah. I mean, but let's unpack your question. How does the casting system know what you mean when you want a string representation of patient record? You know, it doesn't know what, I mean, you've named patient record, you kind of, as a human being, we can say, well, patient record probably is like a name and an address and stuff like that. But for all it knows, patient record is a collection of 1,000 integers and a string ASCII art of a smiley face. It doesn't know what a patient record actually is. So we can only cast things where it's reasonable for it to make at least let's call it an educated guess about what representation you want. In this case, it's a fully custom object. We pretty much have to tell it, this is what I mean by ToString for this guy. Maybe we just get the name. Maybe we don't want all the extra crap. Does that make sense? But the default is I'm going to show you the memory address of this guy. That way, system.out.println can print any object. Because every object we create extends the default object class. And the default object class has a ToString method in it, which displays the string representation of the memory address that was returned by the new keyword when creating that string. Just so that it'll always work. Go ahead.
Then would it be useful to us to leave the default ToString and then make our own ToString?
Depends if you want the memory address ever or not.
I mean, like, what if we're using .ToString, like the default one, for something else not related to the...
Potentially, yeah. I mean, you can do two. I mean, let's go down that path. Let's go ahead and just for the sake of argument here, we're going to choose not to overwrite ToString. We'll just take the default one that gives us the memory address. And so let's just see what this produces for us. Okay? So we're going to effectively let Java make a guess of what we mean for ToString to be for a patient record. Okay? So inside here, I go ahead and I store into my patient strings my patient record .ToString. Now I'm telling you that's going to be a memory address representation of that guy because we haven't done anything special. Okay? What he's suggesting is maybe we don't override ToString. Maybe we create a second function, maybe called formatted patient record that returns a string that happens to be a representation of it. That way we still can get at that memory address if we care. In Java, the memory address doesn't, a string representation of that memory address is useless for us, other than just being able to print it out and proving that two pointers both point to the same thing. We can't use it for anything in Java.
I guess I was more saying, like, if I'm using ToString for the default purpose on another, like, string, let's say I have an integer and then I said ToString, would changing...
We're only overriding it specifically for patient records.
Okay.
Yeah, everything else that's an object, I mean, we can't change it for objects. That top level one, we're not altering the generic object class.
Okay.
Yeah, we're only altering our class that we invented. And instead of getting the default version, we're going to make a change. So let's do it. We'll take the default version first, and we'll just see how this pans out. All right. So I have I have a patient record here. I'm going to ask him to call his ToString method, which is going to give right now a memory address, and we're just going to toss that into our patient strings as our representation of our the string representation for this particular patient record, and then we'll increment the number of patients. Okay, so now we're just doing one extra step when we add a patient record. We're also storing a string representation of it. Okay, so now inside of our page 2, patient record, add new activity, this guy right here, we are getting all of our edit text stuff. We're reading in all the pieces of information. We're creating our new patient record right here. Then we're calling that add patient record function, which adds it to the array of patient records and also adds the ToString version of it to our array of patient record strings. Make sense? And then we are telling this activity to go ahead and finish, which will take us back to the previous activity, which is in main activity. All right. Now, let's just look at onCreate here for a second because we've already been playing around with onResume and onStart and all this stuff from last time, but we'll look at that in a second. What we're going to do initially here is we don't want this string array to be the source of our array adapter for our list view. Instead, we want that core string array, the one we just built, our patient record strings or our patient strings, whatever we named it. So I'm just going to delete that guy right there. He's a string array just like this other dude in core is just a plain Jane string array, right? He just happens to be filled up with string representations of patient records, which are really cryptic looking memory addresses right now. Not the friendliest representation, but this string array right here, isn't that every bit as good as this string array right here. String array is a string array, just has different strings in it, but same kind of animal, right? Okay, so I'm not going to use that guy there. Instead of Bible books here, I'm going to say core dot, what do I call it, patient. Oh, I made that guy private, didn't I? So right now, the patient strings is currently private. If I need to directly access it from outside of here, I either need to make this public or I need to give myself a getter. So you can decide how loose you want this to be. If you don't want people to directly be able to manipulate this array, like if I make this public, people will be able to directly say the patient strings at bucket 2 is equal to LOL. It can break my code. Now, if I'm the only programmer, maybe that's not a problem. I trust myself. But if I want to truly give read-only access to that guy, I can just create for myself a public static string array, get the patient strings. And this guy returns core dot the patient strings. Make sense? By making this variable up here private, that means it is only accessible within the class named core. Therefore, I can return, here's a public method, which is accessible outside of this class, but since that method lives inside of the class named core, I can access this private field of core called the patient strings. We would probably call this correct programming practice. Realistically, if you were slapping something like this together, kind of quick and dirty, you'd probably just make this public. And then not require a method for accessing it because it's already accessible. But do you understand the difference? This gives me read-only access to that guy. In fact, actually it doesn't. Because we're actually getting a pointer to this dude here. So once I have it, I can change it anyways. So when I ask get patient strings to give me access to give me the patient strings, I'm not getting a copy of that guy. I'm getting a pointer to the memory address where it lives. So with that in mind, I can actually just go and make changes to it anyways. So while I might be trying to make this read-only access to the patient strings, because arrays are pointers, because they hold memory addresses, I can make changes to it. So this is actually sort of kind of a waste of time to make this guy a public getter. So since you're doing that anyways, we might say that, just operating in reality, we might as well just make this dude public. Similarly, if we're operating in reality, we'll make the patients public too, but we'll leave it as private for right now because one of the lessons I've taught you is make things private, then loosen the reins as needed, right? So we'll keep that guy locked down because we're not using him right now. But we've noticed that, hey, we need access to the patient strings, and private was too restrictive, so I went ahead and loosened it. Actually, I could have just taken private off, and then it would have been accessible to everything in the package. But we're just saying, look, anybody who gets this anyways can change it, so it's public. Take it if you need it. Okay? So then out here, I can say core dot the patient strings now. That guy's available to me. Okay? So now I'm building my array adapter in terms of this string array called the patient strings. That make sense? Okay, and I'm giving it this default, this list view row that we created right at the end of class last time. I'm going to be showing you a more advanced version of that today. I recognize that this might have been a little bit of a sticking point on the homework because I was kind of rushing through that to get it all squeezed in at the end of last class. So hopefully you struggled with it a little bit. I'll take that into consideration when I'm grading. You had all the text you needed, but I uploaded it to GitHub, but we were going at like triple or quadruple speed at the end of class, so I recognize it. Okay? So, I guess just deal with it. And no, I'll be relatively reasonable. And in the future, I mean, I recognize it this time, but if you think something like that happened in class, when I grade something, if I take off points for something you just thought I just glossed through, just tell me. I'm pretty reasonable. So sometimes I'm not aware of it. I'll find out on the exams whether you're learning what I want you to learn. The homework, I just want you to put in the reps and get out of it what I want you to get out of it. If you struggled with something for 3 hours and learned some stuff about it and it was because I zipped through something, I don't want to punish you for that. Okay, so just be open with me. Okay, so in any case, if you go and look at this guy just real quick, we'll notice that all it has in there is a text view. Okay, we didn't put any layout or anything. We will be putting a layout in there today when we write our own custom array adapter, but this is just our quick and dirty, here's a default list view, you just spit some stuff out. Okay? But we're going to build this dude in terms of this particular string array rather than our Bible book one that we had in there before. Okay? And it just so happens that this string array lives up in our singleton up here. He just has a little bit more global scope. Well, a lot more global scope. Instead of just being lives and dies and on create, he's accessible to the entire application. We made it pretty flexible. Okay? But do we understand that this isn't some sort of brand new type of monster? It's a normal string array that we just put into a more global scope. All right? So one of the things I really want us to, as you become a more advanced programmer, is not to get intimidated by the architecture of an application. So when we sit here and we draw this picture, I mean, this is fairly easy to understand when we drew the picture for this. And I want you to do this for your homework assignments, because if you just sit down and program, eventually you'll be able to. This is simple enough where you'll just be able to conceive upon it in your head and just go to town. But for right now, draw this little thing out and say, look, I need this global variable so that this screen and this screen both can access something in this that this guy has. So draw a little picture of them. Say, okay, what are the things that both of those screens need access to? Well, here's the 2 things we've come up with so far. Make sense? So now, no matter where I am in my application, my 2-screen application right now, I can ask core for these pieces of information. Whereas before, when I just had my Bible books, for example, inside of main activities on create method, the scope of that array was local to onCreate. Lives and dies with onCreate. Make sense? It technically didn't die at the end of, well, in our case here it did because, well, it still didn't. Still didn't. Let me explain that. We had our Bible array in here, right? Which did live and die with onCreate. We had our array adapter here, which was built in terms of that Bible array, which also our array adapter lived and died with onCreate. But we happened to give it, one last little pointer that was hanging on to that guy. Okay? And that's right here. Here's our list view. Even though this local variable list view lived and died with onCreate, he's built in terms of this actual list view that's part of our interface, right? And we set that list view's adapter equal to AA. So even though this variable AA died with the end of onCreate, we actually still had a pointer to the same place in memory inside of our list view's get adapter function. So our list view knew about that adapter. And it just so happens that that adapter also knows about the string array in terms of which it was built. I think that's close. So even though we lost these local variables, technically we had one kind of a dying, one last grasp onto it if we needed to. So you actually could have gotten to these variables. But we're just obviously making it global here. We're saying, in fact, we could even make the array adapter global if we wanted to, and we might have to do that. We'll look at this. But, punchline is we drew the picture. You said, I know I need access to these things, so I'm going to go ahead and throw it up here so that I can get to it from any of these places. Draw that picture first. It'll make your programming life easier. All right? So we've created both of these variables. we are using this variable inside of main activity to create my array adapter. We are also using both of these variables from within our add PR activity through that function that we wrote that sets those sets our new patient record into those arrays. All right. So now, when we first launched this, our array adapter is built in terms of this string array, which currently has nothing in it, correct? But it does have 1,000 buckets. It has 1,000 buckets of nothingness. Does that make sense? All right, so let's see what actually happens here, because those 1,000 buckets should all be equal to null right now. And I'm actually interested in how list views will handle that. You know, does it try to deal with a null value, or does it crash? So let's look at this. It crashes?
Yeah.
Okay, so then it crashes, so what's the fix? Go and fill up that array with empty strings? It's one option. Then you'll have 1,000 rows of nothing, but working nothings. All right, so this guy crashed initially. So now what I can do is I can do this inside of core if I wanted to, but just for the sake of making this work real quick, I'm going to say for int I is equal to 0, I is less than core dot the patient strings dot length I plus plus, and I'll go ahead and say core dot the patient strings at bucket I is equal to the empty string. Or if you want to actually see something, I'll just say n/a. Not available currently. Make sense? So that's like an empty patient. If I really, I can maybe even say empty patient. if I really wanted to say, here we'll do that. Empty patient. All right, so we'll go ahead and pre-fill that guy up with stuff so that he is no longer null values. Now he is string values, just not the permanent string values. We want to have another placeholder string values. So now when I run this, we should get, this will be nice and scrollable too. We should get 1,000 rows of strings. Look at that. Oh, beautiful. Make sense? Okay, now I promise you this isn't the ultimate way we're going to do this. We're kind of limited by what we know right now. Arrays, we just had to create an array that was big enough. Technically, we could just create a 0 bucket array and then make it one larger and one larger and one larger and be really, really, really inefficient, but who cares? We could have done that, but just go with this for right now. Okay? So this guy initializes the array of strings. So there are placeholder strings in there. Make sense? All right, so now what I want to do is when I go to that second screen and I create a new patient record and he adds something to that, let's go and look at that. So I'll go to my, where's my add patient record screen here? So this guy goes in here, he adds that new patient, which updates that string array, correct? That string array now has one more thing in it. Then this activity finishes. We go back to the previous screen. So when I click this, and we'll go ahead and say Mike, and click add. We go back to that previous screen. I'm going to scroll all the way back to the top. It would have been in bucket 0 where that guy would have got added. And notice I now have crazy memory address. That's the string representation of that record. Make sense? Okay. Now we probably want something a little bit better than that string representation of that record. So now we'll go back and we'll either update ToString ourselves, or if you really want to preserve ToString, you can write another function instead of calling it ToString, call it pretty string representation or something like that. But realistically, I don't see a great need for having the string representation of a memory address. Instead, it might be nice for us to be able to do things like system.out.println and pass it an instance of patient record and have it print out what a patient record actually might look like instead of a memory address. So with that in mind, we would come into patient record, and if you just start typing it in here, if you just start typing ToString, and it'll find it in there, and then press enter. So, I mean, you could write it yourself off the top of your head, just knowing this guy is public void ToString, and it returns a string, just because I've written it a bunch of times. But if you know that, okay, I know there's a default ToString, and I want to override it, just start typing the first part of it here, press enter, and it'll go ahead and just give you the kind of the starting point for overriding it. This override thing here is not actually absolutely required. It's a performance enhancement. It tells Java how to do the scoping. So when it goes and resolves methods, it will find this method more quickly than it would have otherwise. Okay, so I'll let it go ahead and give me the starting point. I'll go ahead and fix its curly braces because I don't like them like that. Now notice what it's doing is it's, by default, if I don't do anything else, I've overridden it, right? But all I've done is pass the buck right now. I've just said, look, I wanted to look all fancy, but actually I just let my parent do the work that he was doing before. Okay, so I'm going to pretend like I'm going to do the work. So if I do nothing else, and I just run this again, it'll have the exact same result. It'll look the same as it's currently doing. Because I'm actually calling upon my parents' version of ToString. I'm just passing the buck. So, guy still looks like that, right? All right. Similarly, what if I want that whatever ToString was, but I want to go ahead and tack something onto it? Maybe the put some. So hey, now you got the memory address plus a little asterisk, LOL, high five thingy, something like that, right? Because ultimately this guy is returning a string. What string is it going to return? Well, it's going to return the string that the parent produces. But then before I let it go ahead and do that, I'll go ahead and just concatenate on a little bit more string. Make sense? So now it'll be memory address followed by a bunch of asterisks LOL. Now the reality in this case is I don't want any memory address stuff. I don't want to rely on the parent to do any of that stuff. Instead, we go ahead and do my thing. So we already wrote this for displaying it, so I'm just going to steal that whole string concatenation thing from down there. And that's the guy I'll return. We've decided that's what a reasonable, pretty string representation of patient record would look like. Make sense? All right, so now I'll go ahead and run that. I'll add a new patient record. Click add. Now notice here it has not updated yet. If I scroll and I scroll back down, now it's there. Now it doesn't look like crazy memory address. It looks like something better. All right, that makes sense so far? Okay, now we'll call this would have been good enough, doing it something like this. But really what we want to do is we want to make sure we shouldn't have to manually scroll and come back in order to get that thing to update. Kind of want to maybe force it so it just happens. I gave you this line inside, where is it, main activity? Okay, this guy right here, this line forces a list view to refresh. I put a little hint next to it. All right, so what we're going to do is, so I have access to this variable. Right now, my list view lives and dies with onCreate. So I'm going to make that guy a little bit more global. Okay, and I actually started that last time by putting it up here. So just so our variables match up, I'm going to rename this guy LV. And then I'm setting LV equal to that. Usually I would do this dot LV just because I like using the this keyword to be explicit. Okay. So we actually don't need this line down here because it's going to set initially itself. But what I'm going to do is on resume, we're going to go ahead and, was it on restart? I think on restart's before it shows up on the screen. On resume was after it shows up on the screen, right? So let's actually go ahead and put it inside of on restart. Doesn't really matter for our example, but we'll do it beforehand. So we're going to ask our global list view to go ahead and reload itself. All right, and let's see if this actually will force it to refresh without us doing anything. So there it is, refreshed. Make sense? Okay, so something along those lines for the homework assignment. Go ahead.
Is there a difference between invalidating the views and the notified data set change?
Actually, the notified data set change is probably the one that's made for this. So there might be a difference. I'm probably actually hacking it by using this. I bet you the one you're using might invalidate, but it might do something else in there as well. So what he's saying is instead of invalidate views, it's this dot lv dot notify. Was it defer? Was it notify data set changes?
Yeah, but you have to do it on the adapter.
Oh, it's the array adapter that knows how to do that rather than the list view. Yeah, I'm not sure if there's a difference. This guy seemed to work, but my gut feeling is that probably the proper way of doing it is the way you did it. So let me show that real quick. So I'll go ahead and make my array adapter global in this class as well. So we'll say private this guy. And then I'll just set this dot equal to that in here. But now by moving it global up here, I have access to AA anywhere inside of main activity. So now down here, instead of using the list view to invalidate its views, which probably calls the notify thing on the array adapter, I can tell the array adapter to notify data set changed. I can let him know that the data set actually altered. That make sense? And I can do that on restart. So this should, behaviorally, this should look the same. The difference is who I nudged to let him know to refresh the screen. All right, make sense? All right, so any questions about that so far? All right, so now let's try to be a little fancier about it. All right, so why don't we maybe make our rows, instead of just being a single string, maybe it has 2 lines. Maybe it'll have our name, and then on the next line it'll say age, colon, and then whatever the age is. Just make it a little bit more complex to show an example. All right, and for time, I'm going to go ahead and steal some starter code, but I'm going to modify it for us to see what's going on. But what we'll notice here is by default, we're using the normal plain Jane array adapter. Okay? And in order to make this work, we're going to have to make our own version of array adapters, where we'll take the default stuff, but we'll have to modify a couple of the other things for it. Okay? So I already have a class pulled up here. let me. All right, so this public class movie, this is kind of like our patient record thing that we have. So they have some stuff in here. Don't worry too much about this, but they're ultimately going to show rows that look like this. Here's like an image with some stuff after it. We're not going to put an image in ours at this point, but more than just a single string is what we're going to show. Okay, so they went ahead and they created their layout file. So let's go ahead and do that part first. So we're going to modify our layout file for this to be a little bit, to be ordered a little bit differently. So let me go back here to this guy. Here's my list view row right now. Okay, what I'm going to actually do is, in fact, let me leave this guy. I'm going to create a list view row 2. Kind of give me a better starting point, different starting point. All right, so I'm going to go to layout. I'm going to right click. We're going to say new layout resource file. Okay, and the root element here is constraint layout. Let me cancel this for a second. I want it to be a linear layout. That way I don't embed a layout inside of a layout. So give me a second here. All right, it's android.widget.linear layout. That guy. That's what I want my top line to be. So I'm going to say new layout resource file. So my root element, instead of it being this constraint layout, which I never use, I always replace it with a vertical linear layout. I'm going to go ahead and say android.widget.linear layout. Okay, and then the file name is, we're going to call this guy list view row 2. Or why don't we call it list view row underscore advanced. Yeah, maybe that's a better name for it. List view row advanced. This will be a more advanced version of our list view row. So go ahead and hit OK. Notice it gives me my linear layout here. I'm going to have to tell this guy that he is actually going to be a vertical linear layout. So by default, we click this guy here. Notice his orientation is set to none. So I'm going to go ahead and just tell it to be a vertical one. All right, so now it's my go-to move. Here's my top level vertical linear layout. I can start tossing things in there and we're good to go. Okay. Now I'm going to go ahead and give myself my top line, which will be my text view. All right, and I'll go ahead and I'll put some text in here just so we can kind of see what it might look like. So, but we're going to call this guy name TV. So we're going to give it an ID that means something. All right, and I'll put the starter text in there. I'll be like Mike B. Littman, something like that. All right, then I'm going to drop another text view in here. All right, and we're going to call this guy age TV. The text view is going to hold our age. And then I'll put a placeholder. We're going to say age : 41, something like that. Okay. So we've obviously become significantly more advanced than we were before, but we can make this layout as complex as we'd like to make it. Okay, but we're storing not too many different things. All right, so those are the things we're going to have in there, but notice I've named two IDs, age TV and name TV. All right, so now let me go back to our main activity. So now instead of me building this guy in terms of r.layout list view row, we're going to build it in terms of list view row advanced. Okay, a more advanced version of that guy. But now all of a sudden, it's not going to know what to do by default. Our program would crash right now. Okay, because at this point, it's looking for a single text view to just set the string equal to that. But we're no longer going to feed it an array list of strings. We're going to feed it an array list of patient records. So we're going to need to teach. We're going to have to create our own array list and teach that guy how to deal with patient records. Okay? So let's go back into this guy. So we just built our layout here, which is what they were doing up there. Does this guy let me? I kind of want that bottom part to just go away. Is there an X somewhere? It's one of those really annoying sites, but that's fine. We won't need to be here very long. Okay, so we already have our version of movie here. Ours is called patient record. Okay, so we don't need to worry about that guy. So now we come down here. All right, now in this case, we are creating a new version of patient record. I'm sorry, a new version of an array adapter. So I'm going to go ahead and just copy this code and bring it into our program, and then I'll modify as needed. Okay. So I'm going to go into my package here. I'm going to right click. We're going to create a new, this is a plain Jane Java class. All right. And we're going to call this guy patient record adapter. You don't have to name it. You don't have to have the word adapter in there or anything, but that's what this guy is going to be. He's going to be a special array adapter that knows how to hold patient records. In fact, if you really want to make sure you keep the connection to array adapter, we can call it patient record array adapter. Make sense? So I'll go ahead and hit OK. This just gives us a normal plain Jane class here, right? I'm just going to go after the bottom of this. I'll paste all that other code in. We'll come back to that in a second. And I'm going to change the name of this class from movie adapter to patient record. And this is going to be an array adapter of patient records. And I'll get rid of this stuff here. Now notice we currently have a whole bunch of stuff in red. It's because it needs to import those things, so you can hover over this. On a Mac, you hit Option Enter. On a PC, you'd hit Alt Enter, and that'll go ahead and import array adapter for us. Okay. We're also going to need something called a context. We'll see that in a second. We've used context before, like when we use an intent to launch a second screen. The very first parameter we give it is this. The context we're launching from is this particular activity. So we're going to see this in a few minutes. So I'll go ahead and just make sure we import Android content context. It does that for us. All right. We are going to have a list here of patient records. And this guy is going to be our patient record list. All right, and this guy is going to be of default type array list. Don't worry about those things too much right now. These are collections of things. At this point, we're sort of kind of dancing towards linked lists, which we're going to be learning about as kind of our first new data structure. But for right now, think of this guy as a collection of patient records. Sound good? All right. So now we need a constructor for this guy. Now this guy is going to be not movie adapter, but the name of our class is patient record array adapter. Okay, and this first thing here, this non-null, you actually could leave that off if you want to, but this is saying that we cannot pass a null value to this. And if we were to create an instance of a patient record array adapter, the first part of it is an object. It's a context. And technically, you can represent an object as null. It's saying, look, I'm not going to work if you pass me a null value, so I'm going to go ahead and ask Java to police that for me. Don't give me null values. So I'll go ahead and just do an Alt-Enter on that, and we're going to import the class for non-null. That's this Android support annotation non-null thing. That's this overriding kind of, I'm going to police your code for little things. It's similar to the override guy we had before. Okay. Similarly for this layout resource, that's what this guy is expecting. I'll just do Alt-Enter on that. We'll import the class. Okay, our array list is going to be of patient record, not of movie. Why doesn't it care about that? I bet you they did something special in our movie. I'm just going to take out that layout res. Okay, so our patient record array adapter, this guy here, extends array adapter. So we used array adapters last class and we used it for our homework. Now I'm creating kind of an array adapter plus, a super array adapter. So I am basing myself on everything that an array adapter already has. So the very first thing I'm going to do inside of my constructor here is I'm going to call upon my parent's constructor, passing it a context. What's this guy expecting? Let me go look at, go ahead.
So extending patient record array adapter, or extending that would be similar to importing it?
Not even close. Yeah, extending it means I am one of those, but I'm something more.
Oh.
Okay, just like with our patient record.
So you're just adding to it then?
Let me show you here with patient record. There's an invisible thing here that says extends object. All right, that means that a patient record is one of those guys. He gets everything that makes a generic object an object. But I'm going to do a whole lot more. I'm going to make this guy have a first name and a last name and a middle initial. And so I'm just using this as a base.
Okay.
And then I'm building on top of that from there. So we're creating this patient record adapter. Where's that guy? This dude. We're creating this guy using array adapter as a base. Okay, an array adapter uses something called generics. That's what the syntax is right here. Don't worry about that for right now. I'll explain that later when we start talking about linked lists. Okay, so this guy is saying that there is not a constructor for array adapter that takes a context, an array list, an int, an array list of patient records. So let me quickly go and look at array adapter and look at the constructors for that. This might be using an older version of the constructor. All right, so I'm in array adapter in the documentation. Here is the constructors for array adapters. So we have one that takes a context and a resource. So that's like our resources, like our list view row that we created, list view row advanced. Another one is context, resource, and then text view resource ID. All right, this is the one that I think we're going to be taking: context, resource, and then array of objects. So that's the problem. This guy who's taking in this array of objects, we have an array of objects, we have a list of objects. I think he was taking in an array list of objects. Yeah, here's an array list of objects. So what we're going to go ahead and do is we're going to say this guy's going to take in a patient record array. Okay. And then let me look at the documentation there again real quick. So this guy takes in a context. Maybe I grabbed the wrong context. This is Android content context. It's the right kind of dude. And that's what we have, right? We have Android content context. So this guy's going to take in a context. Is that not like this not null thing? I think maybe it doesn't like this int. Because what we really should be taking in is the layout for this guy. So let me go ahead and cheat and grab that. So it's this dude right here. You can name it whatever you want. But that's going to be like our r.id r.layout list view row advanced guy. So that's what this middle dude will be. List will be an array. Context is a context. This is an int. What are you mad about? Then an array. So I just gave it that. So it looks like right now we're calling this version of it. I wonder if it is not happy with this. Yeah. So it wants us to say we're going to extend a generic array adapter, but now I can take in, we're going to use the array version of this since that's what we did before. So now I can take in a context, the resource ID of my layout, and then here's my array of patient records. And what am I extending? I'm extending a plain Jane array adapter. He's actually going to become an array adapter of patient records, but that's not what I'm actually extending. So I don't know if that syntax would have ever worked or if it was just a bug in their code. But this makes more sense anyways. We are extending a plain Jane array adapter to do our thing. Okay? Now, we are going to set our, and actually up here, I am going to, this is actually going to be kind of a little bit funny how we have to do this, but let's stick with the array world. So I'm doing some deeper modifications stuff here. Instead of being this list of patient records, which looks very foreign to us because we haven't delved into that yet, I'm going to say we're going to have this patient record array called patient record list, and it's going to be a new patient record array of 1,000. That's the limitation we've put on ourselves before. So this is going to still be kind of sketch, but we're going to go about half. We're going to go about as far as we can go right now with what we know. All right. So we're creating our own array adapter. It's going to manage an array of patient records, which we understand that. All right. Here's the constructor for our guy. Constructors match the name of the class. We've done that before. Okay. Our constructor is going to take in the context, which we'll probably pass in this for. It's going to take in the r.layout list view row advanced, and then it's going to take in our array of patient records. And it's going to call the parents constructor to do the initial set up the array adapter dealy. All right. Then we're going to set our context equal to the context, and then we're going to set our patient record list equal to the list that was passed in. Okay, so now our constructor, we're connecting all those dots. So now we have a patient record array adapter. All right, so now we have some red down here. So I'm going to go ahead and I'm going to go to, actually, given that this guy is overridden, I'm going to come down here. I'm just going to start typing in get view. Okay, he seems to think that's what it looks like. So we're going to override a function. So this is similar to ToString. So that means if I go and I look at array adapter, we should find in there a function called getView. And this is the function that's going to get called to fill in the view that is our array adapter. Okay? So in our case, we have a view that has 2 text views on it, right? The name and the age, where before it was just a single text view. So we have to write our own version of this to make sure we can fill in all the little spots in our layout. That makes some sense? All right, so let's just go quickly and look at array adapter. We're going to look at get view. So we're still in array adapter here. I'm going to scroll down to its methods. And we should have a dude in here called get view. Here's get view right here. This guy takes a position. He takes in the view that we're going to be converting, and he takes the view group parent, which the parent of this guy would be our vertical linear layout. All right, so this gets a view that displays the data at the specified position in the data set. So for example, this guy, if we happen to have, well in our case we do have 1,000 patient records, right? It'll call this function 1,000 times. Each time it's going to say, give me the view associated with the patient record at bucket 0. Give me the view associated with the patient record at bucket 1. So on and so forth. Make sense? So we need to write our own version of this guy because the default array adapter doesn't know how to deal with patient records specifically. It doesn't know that we've decided to represent that guy as 2 text views because we're really fancy. Right? We don't have pictures and stuff. Two text views instead of 1. All right. So we need to override this function ourselves. So I'm going to go ahead and we're going to import view. So I'll just click on that and then hit Alt return or Option return on a Mac. All right. We still have the same nullable thing. Import that. We're also going to import view group. Okay. So we have a function called getView that takes in the position. It takes in the thing that the view we're building, the view we're inflating. So this is introducing kind of a new concept in Android where, just kind of like when we have a view and it has gravity associated with it. Last semester when we talked about that, I kind of said, imagine this room, is kind of one of our views. And if we set the gravity to center, we'll all suck to the middle of the room, right? Okay. The way views are generated at runtime by Android is by inflating them, almost like inflating a balloon. So this room here, at runtime, you got the room, then you can set the gravity and stuff like that to it. But that's the way they refer to it, is inflating a view. Okay. All right. So we have our 3 things: the position, the view we're inflating, and if we happen to need it, the parent. Okay. All right, so I'm going to go ahead and get my view. It's calling it our list item, for convert view, but I don't know why they're using different variable names. It's fine. I typically, if you have something that should be the list item, I would have called that list item here. In fact, we still could call it list item here. It's not going to damage anything, but let's just leave it alone. So we're going to say, I'm going to go ahead and have a local variable called list item, which is going to be the view that I'm going to be building here. So it's saying if list item is equal to null, that is, you do not already have this view. Okay? All we have is the ID for this guy. Then we're going to go ahead and set list item equal to, okay, so we're going to go ahead and import layout inflator. So layout inflator, this would kind of be like the clown that blows up the balloons. We're going to bring a guy in to blow the balloons up. Okay, go ahead.
It's like similar to instantiation.
Which part's similar to instantiation?
Like how it gets inflated as grade.
I don't know. I would say it's not a good connection either. Yeah. So, I mean, the idea here is that we've been handed, somebody's asked us for a red balloon. Okay, they're either going to hand us an actual red balloon, but if they didn't hand it to us and we just have the knowledge it's a red balloon, Okay, we're going to call a guy in who's going to go over here and grab the red balloon and blow it up.
I see.
All right. So when all is said and done, after this line of code here, we know that list item will have an inflated view in it. Okay. We need to import. Well, what is this guy? R.layout. Oh, that's actually pretty funny that they're hard coding that in there. So for ours, when we build this guy, here's our text view resource ID. This guy up here, we're actually going to store that. So I'm going to give myself up here a private int text view resource ID. If you remember, the code that they provided us had us just pass a 0 in. We happen to know we're going to pass at the r.layout. List row advanced, whatever we call that guy. So we're going to store our layout ID here. So we're going to say this dot text view layout ID is equal to the dude that's passed in there, which will then allow us to come down here, and when we're inflating this, when the clown goes and grabs the balloon, what balloon is he going to grab? He's going to grab that balloon. That makes sense? So when we first built this array adapter, just like we did before, if you look back here to main activity, when we built our old school array adapter, we passed it a context. We said, this is the balloon we want you to use, and then we passed it our list. That's what we did just for strings, right? So now with our newfangled way of doing this, we're saying, go ahead and still give me a context. Go ahead and tell me which balloon to use. And go ahead and still give me a list. Same thing, right? We're taking the exact same parameters we took before. In fact, we're going to go ahead and just let our parents' constructor do the initial setup. We didn't take any new parameters. We just happen to know that this particular guy here is going to require a little adult supervision. Okay? He's not just a single text view. He's a more advanced layout that I'm going to have to do a little, oversight to make sure that the parts of my patient records get put into the right fields. Okay, that makes some sense? So kind of the point here is what I expect most of you to feel right now is that this is really complex. But as we walk through this, do you start seeing that it's actually the exact same thing we were doing before, and we're able to kind of explain things, and each individual part is actually made up of easy pieces, right? Any hard program is made up of easy parts. We were already doing this before, but now we're holding different kinds of information. Instead of holding strings, we're holding patient records. Now, it would make sense if I don't have strings, I instead have patient records, that I'm going to have to do a little extra when we're setting up our rows, right? I'm going to have some oversight. That's what's happening in here, is that oversight. Go ahead.
I only have one question.
Okay.
Could you remind me once more what a context is?
Well, I've given you the baby version of a context up to this point. We've used contexts. A context in our world is always an instance of an activity. That's not 100% truth. It can be something called a fragment and actually some other things, but it's always an instance of an activity. It's kind of like if I want something to occur within this room, the context from which I'm doing my magic trick is this room. Okay?
So in that case, it'd be the context of the current view that we're in?
It'll actually be the activity. If you go and look back out here, when we passed in that context, what did we pass in? We passed in this, which is an instance of app-compat activity. So we're saying, it's this activity we're putting our list view on. So all this crap is associated with him.
Okay.
All right? And that's actually important because when we build instances of layouts and we build those text views and stuff like that, they get built in terms of that context. So we always kind of have to know which room we're blowing the balloon up in. It's kind of the analogy I'm making.
Okay.
It goes a little deeper than that, but actually not much. I mean, you're getting 90% of it, but it's one of those kind of abstract words that doesn't mean a whole lot. So I kind of like thinking about it like, look, if you're going to show a list of things in here, then the context in which you're going to show the list of things is here. Okay, it isn't really any different than like our Bible homework assignments, right? I'm asking you to read a single chapter, and then within the context of that chapter, asking you to make some comments about how this impact, how this speaks to your life or your vocation and things like that. Okay, so you have this little tiny kind of world view that you're operating out of, even though you know that the Bible has. Actually, one of the fascinating things I think about the Bible is you have always these global contexts. You hear these arguments that people make, like, oh, such and such comment was taken out of context, right? Well, what does that mean? Was it taken out of context from that Bible book? Well, we know that a lot of Bible books relate to other Bible books, right? So you almost have to take not almost, you really do have to take the Bible as a whole in terms of a context, right? And that's difficult. That's why we have theology professors who are experts in that, because it's hard for us to, as normal people, to manage all that data, right? So we have a much smaller version of this. And this is, what room are you blowing the balloon up in? That's the context in which we're doing this stuff. Make some sense?
Yeah.
Okay. Let's go ahead and let's pause here. We might have a quiz on Tuesday. What I'd ask you to do over the weekend is maybe go through and try to review what I've done in this video. We're not at a point where I can give you a homework assignment. If you struggled with the last homework assignment, I'll give you, how many of you did find the last homework assignment a little tough? Why don't we do this? You can go ahead and resubmit that by Tuesday, and I'll give you full credit for your resubmission as well. Okay, so just make sure you have a good understanding of that list view stuff and things like that up to what we did like the first half of class today. So in case you struggled, since I rushed a little bit, that sound fair? Okay, and we'll finish this up on Tuesday. Cool? All right, and if any of you are driving today, make sure you're careful. It's going to suck.
My driveway is just like ice right
Yeah, I drove up from Grafton. The roads actually were not bad. But every sidewalk, every parking lot was insane. I had the concern because I had my laptop in my backpack, and I figured if I go down, that's quite a bit of trauma to my laptop with, my obviously petite nature.
Yeah, I wonder how much trauma I'm putting my laptop through.
That's funny too, because I was just like,